Hey everyone, in this video I want to talk about the in-preview technology, the cross-region or global load balancer. As always, if this is useful, a like, subscribe, comment and share and hit that bell to be notified when I release new videos. Now I always talk about Azure and I talk about, hey, the whole point of Azure is you have this capacity. So we have this capacity in terms of compute and storage and network. And then we really expose that capacity through various types of service. Web apps, storage accounts, VMs, scale sets, whatever that might be. Now the point is that capacity is really offered in terms of regions. So I could think about, well, this capacity exists in a certain region. I'm just going to say region 1, but that could be like West US or Europe, whatever that might be. Remember, a region is a certain 2 millisecond latency envelope. So that really comprises of what we can have within the region. It has to sit within that certain distance. Now, within that region, it's actually made up of different physical buildings often. So there's multiple physical buildings, and where these buildings have independent cooling, power communications, they're exposed as availability zones. So we would kind of see within a subscription, the kind of AZ1, AZ2, and AZ3. Now, not every region has availability zones, but if we actually go and look at the Microsoft documentation for regions and go to geographies, we can see, hey, here's all the regions available. And then we'll actually see availability zones presence down here. And it shows us, hey, if it has AZs or is it coming soon? Is it coming FY 2021, etc., etc. So we can see where we actually have those availability zones present. Now I could absolutely just deploy one instance of my service, a virtual machine. That's not generally a good thing because it could go down. It could go down because of planned maintenance or unplanned events. Also scale, one might not meet my requirement. And so often what we'll do is we'll have multiple instances of our resource. So I might have kind of one over here if we have availability zones. I might have another one over here. So availability zones let me span across 3 different kind of physical structures. If I don't have availability zones, I might use availability sets, where I think about, hey, there's kind of racks of servers and each rack is a fault domain, in which case my resources will be spread over multiple physical racks. So I have now resiliency against a rack going kablooey. But whatever the reason, I have multiple instances of my resource within this region. And that gives me resiliency from failure, and I have more instances running so I can scale better. But I have an end user, and I don't want my end user to have to know about these different endpoints. So what we do is we use a load balancer. So I can think about, well, I have a load balancer resource, and that load balancer resource has a back-end set configuration. In this case, it's kind of pointing to these resources. Now that back-end set and this load balancer, remember, is a layer 4 construct. I can think about, hey, there's kind of the layer 3, which is things like IP. We have the layer 4, which is things like TCP, UDP. And then there's things like layer 7, which would be like HTTP, HTTPS, etc. So when we're talking about the Azure Load Balancer, we're talking layer 4. So it understands TCP, it understands UDP, but it does not understand those kind of application or session or presentation type constructs. It's purely focused on, hey, I understand TCP, UDP, I can do things around protocol, port, source IP, destination IP. So we create this load balancer. Now, obviously, there are layer 7 solutions, things like App Gateway. I'm not covering that today, but be aware that if my traffic was web-based, I may not use the load balancer. I'm probably going to lean more towards things like App Gateway at layer 7 because then it understands HTTP. I can do things like SSL offload, cookie-based affinity, and then things like web application firewall, and maybe even types of caching technology. So back with our focus, I have a load balancer. Now in this case, I'm going to use the standard load balancer SKU. There is a basic load balancer SKU as well. Only the standard load balancer supports instances across multiple availability zones. And also the backend set members for a standard load balancer, yes, can be kind of virtual machine NICs. So it's really VM NICs, which is what we're used to, but it can even be IP address pools. And the benefit of kind of using IP address pools is it gives us better kind of flexibility around it. And also now I can think beyond just things that have a NIC. If you think about a container, well, a container doesn't have a NIC. So how would that work? A container is kind of an IP address. So now with the standard load balancer, I can actually have IP backend pools as well. We could see this quickly. If I just jump over and I look at just my load balancer, this is a standard load balancer. I look at my backend pool. If I do add, notice I can pick, do I want to use NICs or IP addresses? Now that's only a standard load balancer feature. If I look at my basic load balancer over here, I don't have that choice. It's only NICs. It's only going to be in terms of, hey, virtual machine scale set, those types of things. So in this case, I have this standard load balancer configured in my environment. And it's the world's worst website right now, but I've got one sitting in this region. We can actually see it quickly, so if I actually jump back over for a second. So I could go and look at my standard load balancer, and my back end, I have 2 virtual machines. And it has a public IP address. Again, it has to be a standard public IP address. So the SKU of the load balancer has to match the SKU of the IP address. So I also have kind of a standard SKU public IP. Because this is an external load balancer. It has a public IP for that front end configuration. I can also have internal load balancers where that front end is an internal IP, but they don't work with what we're going to talk about, which is the cross-region geo-load balancer. Note, if you have a basic load balancer and a basic front-end IP, there is actually a way now to convert that to a standard without losing that IP address. So that is an option you can actually do. But for right now, I have this super simple site. You can see, hey, I do have this kind of public IP address assigned to it. And within that public IP, let's jump over to public IP addresses. I did give it a DNS name. So you can see my web, and there's its DNS name. And so if I just super quickly go to that, you can see the world's worst website. So I have 2 of them. Depending on how lucky you were, you'd get Web 01 or Web 02. But that's it. That's all this does. So that's great. It exists within that particular region. But very often, I want resiliency against maybe that region having an issue and going down. Maybe I just want multiple instances of my service in multiple regions so they're closer to my end users. Because let's say this was like, for example, let's say this is South Central, or maybe it was in Europe, and I had users on the other side of the world. Well, I'd want to put an instance close to them. So I can absolutely think about Azure has lots of regions, so I might have another region over here. So I could think, okay, so this is, we'll just say region 2, but it's another region with its own set of capacity. And once again, it has its own set of kind of physical infrastructure. Maybe it supports AZs, maybe it doesn't. Maybe I'm just using availability sets if it doesn't. And it'll always be 3 if it supports AZs. And once again, I have some resources. And once again, I'll have a regional load balancer in here that has these as its backend set members. Once again, it's going to be a standard load balancer. So that's kind of its backend configuration. Once again, it's a standard external. So once again, it has a standard public IP. where I could get to that service as well. And I have that as well. So if we go back and look, I have a second public IP address over here. Copy that as well. And once again, we could go to that. And that's in West Central. So that's an entirely different load balancer. We can see it's here, this West Central WC web. And actually I was lazy on this one. This just has a single VM in the backend set. But so it's two separate regional load balancers. Okay, that's great. But now I have to think about, okay, so I have these two regional sets of my solution. What about the end user? If I have an end user sitting here, where do I go? Do I give them a whole set of different possible addresses? And if they jump on a plane and go somewhere else, that doesn't work. They need one single entry point. And this is the whole point of the global load balancer, this cross-region load balancer capability. Because what I want is, I want to go to whatever one is available that is closest to me. And if we think about Azure has this great big global backbone network, which these regions are connected to. There's obviously a whole bunch of other regions. So there's a huge number of regions kind of all throughout the world. This could be kind of region 3. There's another region over here, for example, 5, 6, 7, 8. Huge numbers of regions all over the place. So we have this massive number of regions where we can create services. So we have all these different regions available to us. So what we can now create is this cross-region load balancer. Now, I'm going to simplify it. Obviously, it doesn't just exist in thin air, but I can really think about the idea, let's draw that person down a bit, that I can now create this kind of global cross-region load balancer. And it is kind of a standard SKU kind of thing. And what I can do with this, for its front end, it has this new kind of global public IP address. So it has to be public. And the way this global really works is this is anycast. So what anycast means is this global IP, so we'll call this sort of front end 1. And that's the IP address. This front end 1 is actually existing over here, and over here, and over here. It's anycast. It's available in lots and lots of the regions. Now the back-end pool of this global load balancer are the standard load balancers. That's what can be the back-end set. So the only things that I can have for a global load balancer with the back-end set members, its back-end, are standard load balancers that are externally facing. It's IPv4 only, and when it GAs, it'll have the same SLA as a standard load balancer. So this is what this is going to give me now. I can create this global load balancer. I can add externally facing standard load balancers as its back-end set. And this global IP is anycast, and so wherever I am, it's going to be a very low latency connection to it, and then it will redirect me to whichever one I'm closest to. So you could kind of think about if this user was actually, and I'm sitting over here, for example, the front end IP, when it talks to it, it'll talk to this region, and this region would work out, well, this one's closest to you. This is where on the Azure Backbone Network I'll redirect you to. If this was down, it would redirect them to the next closest one. So that's the whole point of what this kind of anycast is doing for me. Now, when I create these today, I can only create them in certain regions. So if we actually look at the documentation for a second, so there are home regions. So the home regions are the places that actually will support the creation of one of these global load balancers. Now, it does not mean if that region was down, things will break. Notice it says the region doesn't affect how the traffic will be routed. If the home region goes down, it does not affect the traffic flow. So it's calling that out very specifically. And then when we think about that Anycast IP address, well, that's in any of the participating regions. So here we can see, hey, here's all the participating regions that the traffic will actually travel to the closest participating region on the core network. So this is where that global public IP is actually available. And so now if I look at the configuration, so you can see here, well actually if we just did new first of all, I have to pick SKU type standard, it has to be public, but then you'll see I have this option here that I could say global. Now if I say internal, I can't do global. If I say basic, I can't do global. So it has to be a public standard. And then when I do that, and I'm going to kind of jump out of this a second, and let's go to one I created earlier. On the back-end pool of this, I can add load balancers. So here you can see my two load balancers. I can't add VMs, I can't add IP addresses, I can't add NICs. I'm only adding other standard load balancers that are regional. As you can see here, I added my two regional load balancers to the back end. Now today I cannot manually configure the health probe. It's just kind of automatic right now. By default, it's going to poll every 20 seconds to check if the regional load balancer is available. I think that would change in the future. But now I have this global load balancer running, which again, it has its own public IP address that again has to be created in one of those home regions. So this public IP address I have here, so we can actually go and see, there's my global public. It has a DNS name. So remember, this is pointing, resolving to one of those other two standards. If I go to it, well, I'm closer to South Central. I'm in Texas, so it's redirecting me to the South Central one. And that's really the goal of what this is. I mean, it's actually not super complicated. The whole point of this thing is, it's an Anycast IP address, the same thing we see with things like Azure Front Door. It's available kind of everywhere, and it's redirecting me on the Microsoft network to whichever one is available and closest to me. Now, one of the ways this actually differs from Front Door is this is a layer 4 pass-through. So if you think about this, client has a particular IP address. So for things like Front Door, that actually doesn't get passed to the back end. That client IP with this solution, because it's pass-through, will just get passed to the back end, to the app. It can then do certain logic based on the client IP. It is also, you own these IPs in terms of it's part of your subscription. You have full control over. So that's a big difference from things like Azure Front Door. But I will stress, I'm showing this kind of port 80 thing, HTTP. Typically, I wouldn't be using load balancer, I'd use app gateway. And for the global, I'd use Azure Front Door. I'm actually going to post a video in a couple of days where I'll actually go through all the different load balancer options and how you pick which one to use. But my goal of this video was to talk about the global load balancer. And honestly, a port 80 is a very easy, lazy way to show it. But that's the whole point of this. I can now, as a client, talk to this, that IP address is available all over the place. Again, it's resilient from any region going down. Yes, I create the global load balancer in a region. Yes, I create the global public IP address in a region. But if that region is unavailable, it doesn't impact the actual functionality of this. You saw me access it via the public IP kind of DNS name of this, but you could absolutely put a vanity in front of it. I don't have to kind of expose. I could have a www.cws.saviltech.net, which could either resolve to the IP, or it could be an alias record instead of a host and actually just point to the name. So in my example, just to kind of prove a point, I just actually created, let's jump over here. So I created a www.cws.saviltech.net. which resolves to the same thing. If you actually look what I did, if I just open up a command prompt, and if I just do an ns lookup on that www, and you'll see this all over the place. Again, it's just resolving to that. So we can see here, it just resolves to that DNS name and then the IP address of that global public IP. So that's really all it's doing, nothing fancy. But I can hide the name, and I can do that for things like Traffic Manager as well. There's all sorts of different solutions that I could possibly leverage. But that's it. I mean, that's really all there is to it. It's actually a very simple configuration. I just create a global public load balancer. I create a global public IP. Again, I have to create it in the regions that support this, those home regions. The documentation has a limited number of them. But now, essentially, it will just resolve to whichever one is closest to the end user requesting that resource. Again, public only, can't do it for internal today. Standard load balancers on the back end, IPv4, and now it's available wherever. So I hope that was useful. Until next time, take care.